Hello and welcome to the section 10.1 lecture. Today we're going to be looking at the start of Unit 10, which is all about polynomials. And today we're just going to be looking at adding and subtracting polynomials. And I'll give a very basic idea of what this really means. But first, let's get a couple definitions out there as soon as I get this set right. Some of our basic definitions: a term, I'm just going to call that a building block of a polynomial. A polynomial is a collection of terms, not to sort of have a circular set of definitions there. Collection of terms. I'm actually going to go back and talk a little bit more about what a term is, what constitutes a term. And it's built from a sign, a coefficient, okay, I'm going to run out of room looking at how far that's going so far. No, I'm confused. Sign, coefficient, variable, and exponent. Barely fit it in as it is. Okay, so a sign, positive or negative, coefficient, just a number, a variable, typically a letter, and an exponent, squared, cubed, to the fourth power, and so on. Or even to the first power, or kind of to the zero power. So all those four things constitute a term. And so a polynomial is just a collection of terms. A standard form of a polynomial is rearranged to, how do I want to write this? Written, I'm going to make it pretty informative but basic, in descending exponent order. So if I had kind of a common way to write it anyways, using A's for coefficients, I have ax to the maximum power plus ax, let's say a1, a2x, so different numbers here, to the n minus 1 power, so to the next power, a to the third, a sub 3, to the x to the n minus 2 power, all the way until you have a, let's call it n minus 1, to the x power plus a to the n, or a sub n, with no x on it. So just putting them in descending order. So you'd have like an exponent of 3, then the exponent's 2, then 1, then no exponent, and then just a number. Okay, so that's what we're looking for. The degree of a polynomial is, once we have it written in standard form, the highest exponent. The highest exponent of a polynomial. So if the biggest exponent I have is x cubed, then the degree is 3. Highest exponent of a polynomial. The leading coefficient is the number multiplied by the variable with the highest exponent. The highest exponent. My pen's being a little slow, apparently. So leading coefficient, like if I have something like, and I kind of want to give a very basic example. If I have 4x to the fourth plus 3x to the third, I don't want to be super trivial, 5x minus 4, my terms are all these things, all the sign, variable, coefficient, and exponent combinations. That's why I consider them to kind of be the building blocks of a polynomial. Okay, these are all terms because they really, when we're looking at it, terms are separated by plus signs. That's kind of the basic way to look at it. But there's not always a plus sign. Sometimes there's a minus. And so I say that you include that sign in what you consider the term to be. Right, so this polynomial has 4 terms. We're going to use the same number a lot. Let me just change this. Let's make this to the 5th power, just to throw in some variation there. So it's got 4 terms, the 4 boxes. Its degree is 5, right? The highest exponent is 5, and its leading coefficient is 4. Namely this 4, not the fact that there's 4 boxes there, okay? The leading coefficient being the number multiplied by the variable with the highest exponent, okay? So we do some things in classifying polynomials. We talk about them in terms of degree and number of terms, okay? To some, we have some names, and there are other names that live out there, but this is the maximum that I go to. Because really it's a memorization game. Okay, so when we're looking at degree, if the degree is 0, that means that we have something like 5x to the 0 power. Well, x to the 0 power is just 1, so there really is no x there. So it's just 5. We call that constant, because it's just a number. There's no x involved. Linear is when the degree is 1. That's like 3x. And there could even be minus 4 or something like that. Okay, but x to the 1st power. It's a linear relationship. Quadratic is when we have a degree of 2. And cubic is when we have a degree of 3. And I'm not going to put examples of all those out there, but they do exist. And we're going to see some here in a second. And if we have anything that's 4 or more, I wish I would have left room for this, but 4 or more, we just say whatever number it is. I'm going to use a dummy letter for nth degree. You'd say it's an nth degree polynomial. Okay, if it's anything 4 or higher. 4 would be quartic, 5 would be quintic, 6 would be hexic, or sorry, not hexic. Maybe it is. I don't remember. But there's names for all those, but I don't want to memorize all those. Okay, and then we also classify it by number of terms. So the number of items that I have. And if there's 1 term, it's a monomial. If there's 2 terms, it's a binomial, like a bicycle has 2 wheels. 3 is a trinomial. So it has 3 terms, like a tricycle. 4 would be, I don't know why I'm making myself work this hard. Anything here 4 or more would be, so like looking at like nth degree or 3rd degree or 2nd degree, cubic or quadratic. If it has 4 or more terms, and then again, this is after you've simplified it, after you kind of gather all your like terms, there's 4 or more terms, you would just say with, I'm going to use n again, with n terms. Okay, we got to get moving here though. We've spent way too much time on that. So let's go ahead and get through some of these. I could probably do them all pretty quickly actually. The first thing we want to do is write them in standard form. So that means decreasing exponent value. So I have an x to the 3rd, an x squared, and a no x. So we're going to say x cubed minus 4x squared plus 3. And then we want to classify it by degree and number of terms. The highest exponent is 3, so it's a cubic. It's a cubic polynomial. Number of terms, there's 3 of them. It's a cubic trinomial, 3 and 3. Okay. Next one, same kind of thing. I'm going to put the 15x cubed first plus the x. Oh, and it says to identify the leading coefficient, we can say LC for leading coefficient is positive 1. 1 is being multiplied by that x cubed. So that's everything on that one. Maybe I'll just do 3 of them and kind of leave it at that. The next one I have, it's to the 3rd power, so it again is cubic. It has 2 terms, so it's a cubic binomial. And the leading coefficient is 15. The first number being multiplied by the variable is 15. This one's already in standard form. It goes x squared, then x, then no x. And so it is a quadratic because the highest exponent is 2. There's 3 terms, so it's a trinomial with a leading coefficient of -7. Okay, I'm going to leave the rest of those because it's a lot of the same thing and I want to save a little bit of time. I guess I can say them. This one's a quadratic monomial with leading coefficient 8, a linear binomial with leading coefficient -12. This is a constant monomial. There's no x's involved and there's only 1 term. Kind of a scary way to say 18, but somebody could say, oh, that's that constant monomial with leading coefficient 18. Oh, you mean 18? Yeah, perfect. Good job. The next one, I'd have to do a little combining like terms because I have an x cubed here and an x cubed here. So this would actually only have 3 terms, but it'd be a cubic trinomial with leading coefficient 19 when I add those together. This one, I would switch the place of these two. I'd have -13x squared plus 4x minus 11. So it's a quadratic trinomial with leading coefficient -13. This one is a quadratic binomial with leading coefficient -42. So that's all the different ones of those. But writing them is going to hurt my hand and just be a pain. When we're adding and subtracting polynomials, it is literally, I don't know what I'm doing. I was about ready to write common denominator, it looks like. Combine like terms. That's all we have to do is combine like terms. Now, sometimes if it's a subtraction problem, we've got to talk about, well, we've got a negative out there that we have to distribute, but for addition, it's literally combine like terms. And try to write them in standard form. I'm going to put my x cubed first, so I have 3x cubed. I also have an x squared. And so a lot of times I'll go through here and I'll use different underlining strategies just to highlight the things that I have that are the same. Okay, I have an x cubed by itself, an x squared by itself. I have a couple x terms, -4 and -3. That's going to be -7x. And then a couple number terms or constant terms, +3 and -5 is -2. Okay. When I get a subtraction problem, the first thing I should do is rewrite with distributing the negative into the second one. Think about multiplying all these by -1 or just simply switching their sign. -2x squared minus x plus 1. And now I would go through and I'd say, all right, I'm going to give my x squareds this little square bracket idea. My x's are going to get a little loopy underline and my numbers are going to get a little squiggle. Now I just want to combine everything that's underlined the same. I have -x squared, -2x squared, that's -3x squared. +3 and -1x is going to give me 2x. And -4 and +1 is going to give me -3, and I'm done. Okay, I don't want to make this harder than it has to be. It's literally combining like terms. This one's a subtraction, so I'll go through and I'll rewrite it. Negative 3x squared plus x plus 8 minus x squared plus 8x minus 4. So I took all these signs and I switched them. And I actually switched the one right in front of x squared. That was kind of an unwritten negative sign. All right, but x squared wise, I've got a negative 3 and a negative 1. That's going to be negative 4x squareds. Positive 1 and positive 8x, sounds like 9x. And then positive 8, negative 4, sounds like plus 4 for the constants. Next one's addition. I don't have to rewrite it. I could just go at doing it, underlining the way I need to. I've got an x cubed. I've got an x squared. I've got a couple x's. And I've got a couple numbers. Right? I just randomly pick an underlining strategy on each one of those. Notice this is the only kind of square bracket underline I have, so it's just going to get copied down. Same thing with this one. Minus 3x squared. Negative 2x and negative 6x is a negative 8x. And negative 1 and negative 2 is negative 3. So if we were doing the thing from before, we'd say, oh, it's a cubic polynomial with 4 terms with leading coefficient 5. And that just, the reason we say that, the reason we bring that up is that it gives a lot of information about what the graph would look like if we were to graph it. That's why we want to know all those things. Cubic has a certain shape. 4 terms is going to tell me a little bit of information about it. It has something to do with how many times it changes directions. And then the leading coefficient kind of tells me how steep it is. More importantly, tells me which way it's going up and which way it's going down. But that's all information that you get from that simple statement. You can graph very general ones just by knowing that information. The next one, I've got a plus, I'm adding. So I'm just going to combine like terms. I've got some x squareds, I've got some x's, and I've got some numbers. X squared wise, I have positive 4 and negative 5, so that's negative 1x squared. X wise, I have negative 2 and positive 1, that's negative x. And numbers wise, I have negative 9 and negative 7, which is negative 16. So a quadratic trinomial with a leading coefficient of negative 1. Not too bad. And I mean, to put some of that to good use, I know that this graph is going to look something like, it's going to start low, it's going to have some kind of a swale in it, some kind of up and down, and then it's going to end low. Okay, and that's just what I know from that comment, that it's a it's a quadratic trinomial with leading coefficient negative 1. Probably doesn't look quite like that, but it does tell us a lot of information that we use in a later class. Last one we have here, let's go ahead and combine like terms, but we do have subtraction, so I'm going to rewrite it. Minus 3 plus 7x squared minus 3 plus 9x squared plus 2x. Okay, so I have a 2x, a 2x, a negative 3, a negative 3, and a plus 7x squared plus 9x squared. It's going to be 16x squareds plus 4x minus 6. Okay. Hopefully you got something out of today. Go ahead and put any questions you have in the space on the left. Otherwise, I hope you have a great day, and we'll see you in class.